Realistic human motion synthesis is very difficult. Current state-of-the-art still requires an exhaustive database including all possible actions and transitions to perform a realistic style transfer. We propose a new spectral style transfer method which performs style transfer between independent actions. In this example, a run, walk, jump sequence is stylized with a database of only punch and kick actions. We draw our intuition from the fact that it is difficult to correlate time domain signals of independent actions, whereas the correlation is easily observed in the spectral domain. Our core method decomposes each degree of freedom of the skeleton hierarchy independently into the spectral domain. We then analyze the difference between a source and reference action available in the database and apply this difference to the input motion in the magnitude component of the signal. Using the original phase information to keep synchronization intact, we reconstruct the stylized motion. We then generalize our method to arbitrarily long and heterogeneous motion sequences by introducing a sliding windowing function for temporal localization. We also add binary terms based on parent and child degrees of freedom to take into account the style components in the phase synchronization. We now compare our method with recent work. Note that when all actions are available in the database, both methods result in similar style transfers. When the database is constrained to only walk action, the transfer of the comparison significantly deviates from expectations. Here, a heterogeneous sequence is stylized with a limited database where the kick and transition actions are missing. We first compare both methods using a fully inclusive database. Here, we see the results of both methods with the limited database. Note that the comparison cannot reconstruct the kick motion. And the transition to jump is not smooth. Taking the previous method's style transfer using the full database as ground truth, our method performs more than 8 times better. Here, we compare both methods with a limited database where the jump motion is missing. An immediate use of our method is to enhance existing databases with missing actions to facilitate better performance for alternative approaches. Here, we can see that once the jump motion is filled in with our method, the alternative approach can generate a more realistic style transfer. Using the enhanced database generated by our method, the comparison performs almost 6 times better. In this example, the transition and jump motions are missing from the database. Note the diminishing stylization at transition and consequently at jump time. After enhancing the database with our method, the previous work's performance approaches to our style transfer. In this example, we compare against 2 previous approaches where the running motion is stylized using a database of only walk action. We can see that both our method and previous methods using our enhanced database perform significantly better compared to previous approaches using the limited database.